Hi, welcome to another Brain Crane video. Today we're going to learn about the Pythagorean Theorem. So why was the Pythagorean Theorem invented? Well, first of all, it was invented by a Greek philosopher named Pythagoras, and it is now used in everyday math to find the missing length of a right triangle. So this is a right triangle. At the bottom left you see a red square which represents that angle is right, or in other words, it's a 90 degrees angle. Every right triangle consists of three parts. There's leg 1, which is equal to a variable, which is required for the Pythagorean theorem. Then you have leg 2, which is equal to variable b, and these variables will be required in the equation for the Pythagoras theorem. And then you have the hypotenuse, which is variable c. Using the Pythagoras theorem, we will be able to find a missing hypotenuse or one of the missing legs. So now that we know the different parts of a right triangle, we will now be able to use the Pythagoras theorem equation. For this, the equation is a squared plus b squared equals c squared, and this can be interchanged to find any of the missing components. Now that we have the equation required to do the Pythagoras theorem, let us try with an example. So in this triangle, we can see that leg 1 has the value of 3 and leg 2 has the value of 4. The first step that we have to do is substitute all the values that we know for the variables. So we know 3 is a, so we replace that for a, and 4 is b, so we replace that for 4. The second step is to do what you know. So we know that 3 squared is equal to 9, and we know that 4 squared is equal to 16. That way we know what each number is worth, and now we know that 9 plus 16 is equal to c squared. The third step is to combine like terms, and we know that 9 and 16 are two integers without variables, so we add them together and we get 25. So now 25 is equal to c squared. The last step is to get the square root of both sides so that c is alone and it's not c squared anymore. Now it's just c. So we get the square root from both sides, and the square root of 25 is 5. So now we know that 5 equals to c. Now that we've finished our first example, let's move on to our second. The second example is a little different. We have a hypotenuse and we have leg 1, but we don't know what leg 2 is. So now we're going to follow similar steps, but it's going to be a little different to find the missing leg. The first step is the same as the last example, where you have to put in what you know. So we know that 10 is the hypotenuse, so we replace that for c, and we know that 8 is the leg 1, so we replace that for a. Step number 2 is also the same as the first one, as we have to do what we already know. And we know that 8 squared is 64, and we know that 10 squared is 100. In any algebraic expression, we always have to isolate the variable, so we move the 64 to the right side. So we have to do this by counteracting the positive 64 by subtracting 64. 100 minus 64 equals 36. Now this last step is the same as the last example, where we have to take the square root of b squared, which is just b, and the square root of 36, and the square root of 36 is 6. Therefore b is 6. Now we know how to utilize the Pythagoras theorem to find either a missing hypotenuse or a missing leg.